So hello students, in this PowerPoint presentation we will talk about the biopsy of serotonin using rat fundus strip by 3-point biopsy. As in the earlier presentation lecture, I have told about the uh, matching biopsy, interpolation biopsy. Now this is multiple point biopsy in which we are going to talk about the 3-point biopsy. So as we have discussed the detail in what is biopsy, serotonin is a autocoid and basically it is responsible for the contraction of rat fundus strip through the 5-HT2B receptor, and this diagram is representing this is the fundus part. This is the uppermost part of the stomach, which is fundus part, and this is the fundus. This is the exposed part of fundus. So this is the cut. The black color dot line represents the cut of the fundus strip. So starting from the requirement, so in this we require the rat and overnight fasted rat, and basically we require the fundus strip, and these are the specific term and condition what we require for this experiment. Basically when we talk about the rat fundus basically it can respond to serotonin, 5-HT or histamine, acetylcholine, bradykinin. Basically like the ileum is a fast contracting smooth muscle, but when we talk about the rat fundus, it falls under the category of slow contracting and relaxing type of tissue. Basically we use the biopsy of serotonin in the rat fundus strip, and it performed through the 5-HT2B receptor activated GQ protein mediated calcium release, and thus produces the contraction of rat fundus strip. And in this presentation, in this 3-point biopsy, how we will perform, how we will take the DRC, I will discuss in the detail. Why we are what is the significance of 3-point biopsy? Basically the precision, reliability and the reproducibility of the assay methods are too high. What is the meaning of reproducibility, reliability and the precision? I will discuss in the later slide. So now this is the procedure. What we have to do, we have to there are various methods for the sacrification of the rat, and these are the following method that we have to perform for 3-point biopsy. So basically this is the Latin square design that we have to draw for this 3-point biopsy, and basically this is the DRC representing the 3-point biopsy. So in the first step what we have to do, that we have to take the DRC of a standard, as we have taken here 0.1 ml, 0.2 ml, 0.4 ml, 0.8 ml and 1.6 ml. You can go for 3.2 also or 6.4 also. It means ultimately you have to check, you have to stop your presentation when you get the sub-maximal response of the standard. So as we are considering that 1.6 ml is the maximum response, and after this if we are assuming that if we administer the 3.2 ml, the response will be again 19 mm. It means from here this tissue is producing the sealing effect. So as 0.1 ml it is showing the response of 6 mm height, 0.2 ml it is the respected height written in the upper side. So for 0.4 ml it is 12 mm, for 8 ml it is 16 mm, and for 1.6 ml it is 19 mm of standard. So what we have to do, we have to take we have to select here, because 3-point biopsy is also known as 2+1 biopsy. What is the meaning of 2? 2 means here we have to select the 2 standard doses and 1 test dose. That's why we call them 2+1 biopsy also. So 2 standard doses. What is the parameter? How we will select 2 standard doses? The minimum thing is that the S1 and S2, whatever it is, the S1 and S2 in the 1:2 ratio. So let's suppose the S1 if you have chosen the 0.2 ml, right? So S1 I have chosen the 0.2 ml, and the S2 must, as we know the S1 and S2 ratio is 1:2, so S2 must be double. तो double means response की हम इसमें बात नहीं कर रहे हैं, हम बात कर रहे हैं double means dose की. So if S1 is 0.2 ml, then S2 automatically it will be 0.4 ml, again as it is written here. So again after the ceiling effect we will start giving administrating the test solution. And what we see actually, as in the test solution, 0.2 ml is responding to 6 mm of height, right, and 0.4 ml responding 9 mm of height, and this mm of respective height. So what we have to check in this test selection, we have to check, because we have to select one test dose. We have selected already S1 and S2. So how we will select the test dose? Test dose must lie in between the response of S1 and S2. As the response of S1 is 0.2 ml, it is 8 mm of height, and S2 0.4 ml, it is 12 mm of height. So whatever the test solution we will select, the response of that test dose, that must lie in between 8 mm and 12 mm. So the response here, it is 9 mm, that is lying in between 8 mm and 12 mm. So the response at 9 mm, which is giving by the dose of 0.4 ml, so we can say that dose T is for 0.4 ml. So again, if after the completion of this, after the selection of standard and test dose, what we have to do, we have to draw a Latin sequence design. Latin sequence design, it means we have to administer the drug in a manner like S1 T S2, and again if we have chosen the T, so T is here, then S2 is here, then S1 is here. Again we have chosen the S2, then S1 and T. So this can be a number of changes, number of interchange in between the S1 and S2. So again what we are doing, we can see through the Latin sequence design, we are administrating 3 times S1 T S2, and again this and this. It means if S1 we are giving in this pattern, again we are giving S1 here, again we are giving S1 here. Same for T and same for S2. So what is the role? As I have earlier discussed, basically this bioassay is responsible for high precision, reliability and reproducibility. Reproducibility means here we are checking again for same dose S1, we are giving 2 to 3 times. So we can easily check the whether the dose from that particular dose the tissue is responding same or different. So we can also check here the sensitivity of that particular tissue for the same dose many times. So we can check, we can say that here the reproducibility of this assay is too high. So this is the significance of this 3-point bioassay. So through this manner, S1 T S2, we have administered S1 T S2, and then at T S2 S1, this is T S2 S1, and here S2 S1 T S2 S1 T. The response like S1, it is giving 7 mm height, here the S1 is giving 8 mm of height, and here the S1 is giving 6 mm of height. So what we have to do, we have to take the average of these height. So in the next slide, what we have to do, as given, as we know, the concentration of standard serotonin, it is 10 microgram per ml, right? It is 10 microgram per ml. So for S1 we are taking 0.2 ml. So we can say if it is 10 microgram for 1 ml, for 0.2 ml it is 2 microgram. Again for test dose we are administrating 0.4 ml, but we do not know what is the strength of test, that we have to calculate through this bioassay. So this will be like a question mark. For S2 it is 0.4 ml, so this is 4 microgram. So height for S1, for Latin sequence design, it is S1 7, again S1 8, and again S1 6. So here it is T, and here it is for S2. The average of these are like H1 means the through the dose 0.2 ml S1, the response height is 7, and again these are the different height of S1. The ultimate response of this height is mean height is H1, and the response is T, dose is T, and the capital T is response height, and here the dose is S2 and the response of the S2 is capital S2. So what we have to do, we have to calculate, we have to apply the formula of 3-point bioassay. This bioassay formula says the concentration of test is equal to concentration of standard and S1 upon T into NT log T minus H1 upon S2 minus H1 into log S2 by S1. So this is the formula. S1 and S2 is the lower and higher dose of standard, T is dose of test, T capital T is the average height of test, and H1 and S2 are average height of the lower and higher dose of standard. So we have to put the formula in this value, and what we have to check, we have to calculate this, and we have to separately calculate the log 2. We have to put the log 2 and we have to calculate this. Again, for the log 2 value, we have to multiply this value from the value which is coming after solving this 2.67 upon 6. So the ultimately whatever the value will come here, we have to calculate the anti-log of that. So ultimately through these values we are getting 6.8 microgram per ml of test solution strength. So this is the method through which we perform the 3-point biopsy. So for this particular data, the known concentration of serotonin 5-HTUG rat fundus strip by 3-point biopsy was found to be 6.8 microgram per ml. So these are the questionnaire that a student must know after completion of this experiment, right? And these are the references from where I took the information. Thank you very much.